I'm Terrell Henry. Today I'll be doing my oral reaction template. So the first one will be understanding science and overview. The main points of this was science is knowledge of all that exists. Science gives us advancement in technologies and help us learn about health and our environment. Science is how we learn about the world and how it works. Scientific ideas are relatable because they have constantly been tested. There's rarely times where an experiment is tested one time and that one time will give you the answer that you're looking for. So on to the second one, the real process of science. I believe the main point of that is that science circles back on itself. And I want to give a quote from the reading. Successive investigations lead back to the same question. So it's saying successive investigations, the one that are successful, it always leads back to the same question, which would ultimately mean that science circles back on itself. Another one would be that any point in the process leads to many possible next steps. So obviously the process is the same, and just because circles back on itself doesn't mean that there isn't many different steps in the process as well. And those steps, they could have a variety of outcomes. Next one would be a blueprint for scientific investigations. I feel like the main point in that would be scientific testing is at the heart of the process. One of the points I have for that is that just gathering and interpreting the data into whatever you're experimenting, you can't do anything without the data. The data is what's ultimately going to show you whether or not whatever you're testing, if your hypothesis is correct or incorrect. Another one would be that the scientific process influences society and is influenced by society. So, obviously, for example, we are definitely advancing in technology more and more every year, especially looking back at somewhere from even the 2000s to now. The technology we have to test different scientific experiments, obviously the society is changing because our technology is advancing, so the scientific equipment would also be advancing, and it's going to change with the society. So the next section would be exploration and discovery. The main point for that one to me is scientific investigations rely on making an observation. And then, one of the points I added for that is they're not enough to launch a scientific investigation, and that they make connections between ideas and observations. You cannot have an investigation without an observation. You can't have an experiment without observation. You have to observe whatever you're studying before you can get into any type of experience, and that's just the basics of it. You can't do anything unless you observe it first, take notes, get the data of it before you just start going in and experimenting different things. So the next section we have here is observations beyond our eyes. So the main point for this section was observations can take many forms. You can make observations by seeing, feeling, or smelling something. So obviously, if observations, they can be taken in many forms. You can see observation, whether you're doing something with, we'll take a potato for an example, and if you're observing it for a week about the amount of sunlight makes it rot or something like that, you're physically having to see the observation, and you're going to see the change in the potato over time from day 1 to obviously day 7. Then there's feeling. we'll take the potato again for example. Maybe the heat from day 1 to day 7 has changed the shape of the potato. Maybe it's rotten out, the mass is less. So I feel like that's also. And then smelling, I feel like also a potato could definitely have a different smell from day 1 to 7. Obviously, me personally, I wouldn't suggest, observing a potato for its smell. Something maybe like something with a stronger smell, maybe like an onion or something like that. I feel like that will help. And then you can make observations with telescopes or microscopes. That would have to do with astronomy and outer space and stuff like that. But those are two that would deal with the telescope, rather me say. So telescope would deal with looking into the stars or something like that, where a microscope, you'd use that to maybe look at cells or atoms or something like that. So observations, they can be taken in many forms. Those are just 5 forms, and there's many more. Next section would be testing scientific ideas. So the job of science is to collect all explanations and use testing to filter them. And then one of the points I have for that is, if the idea is correct, what would we expect to see? Does the expectation match what we see? So you have to correct. So to find out if the idea of your experiment is correct, you need to have a hypothesis, and you need to check and see if that hypothesis is correct or incorrect, and the data would match whether your hypothesis was incorrect or correct. Next section would be the logic of scientific arguments. Main point I have for that is scientific ideas, expectations, and observations equal scientific arguments. One of the main points I have for that one is evidence can reflect on the ideas in many different ways, and all testing involves making some type of assumptions. The scientific ideas, you're definitely going to have arguments. There's going to be people who believe one thing and people who believe a completely different other thing. And one of the best ways to get to the bottom of that would be having a test, to see if one person thought that, the potato, it's going to stay the same all 7 days, but another person was like, hey, I think the potato would change over 7 days. I think the only way for you guys to get the right answer would be to do that test. And the evidence is going to reflect on what happened to the potato, and that will ultimately determine whether your hypothesis was correct or incorrect. Next section would be tactics for testing ideas. Lost my place. An experiment tests some factors in the system to see how it affects the outcome. Experiments are distinguished from other sorts of tests. Experiments, since they're distinct from other type of tests, an experiment on a animal would obviously be different than they're obviously different than a test on, say, the potato. They're obviously going to have different, experiment is like you experimenting on something, maybe like adding something into the potato, or maybe like trying to make something. I feel like there's a big difference between experiments and tests. Next session would be digging into data. Main point I have for that is tests generate what scientists think as raw data. Data becomes evidence when it reflects on scientific ideas. So since the data becomes evidence, it will obviously, sorry, my notebook keeps flipping over. So since that the data, it is, wait, I actually have that wrong. Okay, I have that wrong thing there. I actually have data becomes evidence when it's reflected on the same scientific idea. I actually might have said that. I really don't remember. But anyways, I'll go with it. So I think the main reason I put that one is because the only way that I think it can be interpreted in different ways, the same data, is that one of those is raw data that has not been messed with at all, that is data that you get and has not been touched with at all, and it basically still is the same data as something that you could mess with, as long as it's something that is like a major change in the data. So I think obviously you would still see, I think you just add something a little different, you will see different results. So okay, next one would be reviewing test results. Main point I have for that is scientists compare ideas about how something works and tries to figure out which is the most accurate. Experiments and observations had long supported the idea that light consists of waves. The results of the project had a refute of different ideas. So I think that one would be that experiments, they come in lights of ways. There's gonna be days where your experiments work, there's gonna be days where your experiments, they're completely wrong. So I think that's what it means whenever it's saying waves of light. Next one would be competing ideas, both a perfect fit for the evidence and other considerations. I put the main point there with scientific ideas depend on interactions within the scientific community. Scientists trust the ideas that explain the observations. The only way a scientist is going to believe what you say is if you show him evidence from an observation that you've made and show him why it is incorrect of what he did and why yours is correct, which meaning you'd have to make an observation. Okay, next section will be making assumptions. All scientific tests involve making assumptions. But let me rephrase that. So I think the main point is all scientific tests involve making assumptions. So reasonable assumptions can be tested and expectations generated by ideas. So I think for you to make a scientific assumption, you would have to, for any type of reason, there'd have to be a reason for you making the test. So you would have to make an assumption somewhere. There has to be a reason for you doing the test, and that reason would be that you are that you're curious about something. So you'd have to make an assumption like, I do think this potato would change, and that'd be a reason for you to do the test. Next one would be analyzed within the scientific community. Interacting in the scientific community is an essential component to the process of science. The community generates ideas and the community evaluates evidence and ideas. So I think that the scientific community, they are essential for, as they're essential for everything. I think they all have to come together and generate different ideas. People all think different. Not everybody thinks the same. Everybody thinks out the box very differently. So all of them coming together and they have to generate ideas, and then being able to be like, oh, that's a good idea, let's try to test this out. So they'd have to test the ideas and the evidence. Okay, next section is publishing research. Journal articles are important ways for scientists to distribute information is the most important part to me. Journal articles clean up the messy processes of science. Next section is copycats in science. The process of science doesn't require every study to be repeated. It is standard procedure for scientists to repeat results before publishing. I think that means to me is that, not that if you just do it one time and you get it, I don't think that really counts as too much. Sorry about the light in the back. I don't think that counts as too much. I think you need to test the same thing multiple times and see that you get the multiple of the same answers in order for that information to be correct. Okay, next we have science benefits of science. The process of science is a way of building knowledge about the universe. The cycle actively serves to construct and interrogate scientific knowledge. The knowledge is used for designing bridges and slowing climate change. Our knowledge of science has increased so much that I'm able to have a phone that we test different things like the internet and building bridges, seeing that we do have climate change and just different things like that. Section science at multiple levels. The process of science works at multiple levels is the main point to me. Scientists form hypotheses based on prior experiences and knowledge and logic. So a scientist who's repeating the same thing, he had a hypothesis before and he had an experience with whatever experiment he's doing that made him have that hypothesis. And his knowledge about that is also the same reason for him having his hypothesis. And the last section we're going to do today is even theories change, and I think the main point there is theories are the best explanation of how the world works. Theories generate accurate expectations and offers satisfying explanations. So theories are how we get the answers to everything. We have to have a theory about something. I'm not saying all theories will be correct and all theories will be right, but theories are how we get answers, because we do eventually get the right answers from theories. Whether it's right or wrong, we're going to get the right answers. If my theory is that the potato will not change and it does change, we still get the answer to that because of the theory.